Greetings everybody, welcome to our first lesson on Chapter 4 on bivariate data. And in this sequence of lessons we're going to be looking at relationships between two different variables. And I will show you what I mean. I'll firstly give you a couple of examples of what this might involve. Let's say, for example, that we thought that there was a relationship between the amount of alcohol consumed per week, for example, and domestic violence. And so if we wanted to see if there was some sort of relationship between these two variables, we would do an investigation or a survey of some sort and would come up with some data. And we might do a survey in a community where we ask participants to describe whether they drank not very often, regularly, very often, or even ask them to describe how many glasses they might drink per night. In the same community, we might also ask or try to get statistics on the amount of domestic violence in that community, and what we'd be interested in looking at to see if there is some sort of relationship between the alcohol consumed at home, between some members of the family, and domestic violence. And so what we might do, we might end up with a graph that looks like this. We would have alcohol consumed here, and the incidence of domestic violence along here. And the graph by graphing this data, we might get something that looks like this. And this is I'm just making it up. And so with this data, we'd want to see if there is a link between these two. And the way to do that is to find how strongly these two are correlated. And to describe that, we use what's called the correlation coefficient. And that's often signified with a lowercase q. And we'll come back to that in a moment. Now, you might see, if we look at this data here, you might notice there's some sort of a general trend that as the alcohol consumption goes up, generally speaking, the amount of domestic violence is going up. So that might suggest to us that there is some sort of a relationship between these two variables. On the other hand, if we did another investigation on something completely different, maybe we want to find out if there was a relationship between the height of an individual and their intelligence, their IQ, in other words. We might do an investigation where we survey a range of maybe 100 people or 50 people. We ask for their height and we ask them to sit an IQ test and look at what score they get. So we might then plot that data. And on the bottom axis, we would put the height. And on the vertical axis, we'd put the IQ score. And we might get a relationship like this. The data might look like this. And if that data looked like this, we could possibly see, or our interpretations would mean that there's actually no connection. We have high IQ scores of people of low height, high IQ scores of people of high height, low IQ scores of people of low height, low IQ scores of people that are tall. So here there would be no relationship. And so by looking at the scatter plot generated by the two variables and looking at the shape of it, we can get a general idea of how strong the connection is between the two variables. So here we would conclude there's no correlation at all. Here we would conclude that there would be a moderate positive correlation. And what I mean by positive, I mean that if we look at the general trend of the line, it's going upwards like this. It's a positive gradient direction. So it's a positive trend. We might do a third investigation where we might look at the behaviour of P-plate drivers, and we might do a survey, or we might actually get the police to deliver statistics on survival rate of car accidents and the speed with which the car was travelling when the accident occurred. And so we want to do an investigation on speed versus survival in an accident. And we might draw a scattered graph like this, where speed is along the horizontal axis and the survival rate is along the vertical axis, and we might get something that looks like this. Now, if you've got a shape like this, which is actually quite close to a straight line, that would suggest that it's a very strong correlation. So this is telling us that there is actually a very, very strong connection between the speed with which an occupant is travelling and the survival rate of that occupant if they have an accident in the car. And so what this chapter is about is us looking and investigating different ways of analysing relationships between data. When we're drawing a scatter graph, we're looking at two variables. The horizontal axis is always, or nearly always, the independent variable. Now I'll explain what I mean by that in a moment. The vertical axis is the dependent variable. Now, to give you an example of independent variable and dependent variable, let's look at an investigation that might look at the number of cigarettes smoked per week versus the probability of acquiring some lung disease by the age of 40. By the age of 40 years old. Now, if we're going to look at this investigation, what we ask ourselves is, what do we expect will have an effect on the other variable? Do we think that lung disease will cause the number of cigarettes to change? Or is it more likely that the number of cigarettes we smoke determines lung disease? Well, clearly, we think that it's the number of cigarettes that smoke will affect the chance of getting lung disease. So this is what we'd consider to be the cause, and this is the effect. So one way of thinking about independent and dependent variables, think of the thing that's causing the effect is the independent variable. So I might put this as the cause here, and this would be the effect. So if you're not sure what's the independent variable and what's the dependent variable, ask yourself the question, which is causing which? And the causal agent, the one that's creating the situation, is the independent variable, and the thing that's affected is the dependent variable. Okay, here are a range of different examples of correlations. Now, this group over here on the left-hand side are examples of positive correlation. And what a positive correlation is when increasing in the horizontal variable, so as this one increases, so does this one. Think of it, another way of thinking about it is a positive correlation means the line of best fit is going to have a positive gradient. Okay, so this one here, that's an example of a strong positive correlation, because there's definitely a very close linear connection between these two variables. In the second diagram, the correlation is not as strong, it's not as linear. There's generally a trend that seems to be going in this direction, but it's not as defined, not as clear-cut as the first one, so we would describe that as moderate. And in this third case, there's no clear relationship between the two variables at all. In this situation, we would describe this as no correlation. On the other hand, of course, we can have a negative correlation. And what describes a negative correlation is if the horizontal value is increasing, getting larger, the vertical value is getting smaller. And so we could think of this as a correlation which has a negative gradient. So that we'd say that's a negative gradient. In this first example, once again, we can see there's a strong relationship. Here, this is an example of a moderate negative correlation. And once again, over here, there is no relationship, so we would describe that as no correlation. So that's just a summary of a general description of the different types of correlation that you can have when we're talking about bivariate data, and if we're talking about a linear relationship. We described how we can just generally visualize a range of correlation strengths by just inspecting the graphs. So for example, remember, this graph we would consider to be a moderate positive correlation. But there's actually a much more accurate way of deciding whether the relationship is positive, moderate, weak, or non-existent. Rather than just using our eye and just approximating, we can actually use a process to come up with what's called a correlation coefficient, or a value that actually tells us how strong the relationship is between the two variables. And that value that we can work out is called the correlation coefficient, and we designate it with the letter little q. Now these values down here that I've drawn represent the possible correlation coefficients. The minimum value that it can take is -1, that's the minimum, and the maximum value is +1. So the correlation coefficient must be a value between -1 and +1. Now if you get a value between, let's say, -1 and 0.75, so if your correlation coefficient ends up a value in there, then we would call that strong. But that would be strong negative because it's a negative value. On the other hand, if you get a value of 0.75 and +1 over here, that's also strong, but that would be a strong positive Q value or a strong positive correlation coefficient. So anywhere between -1 and -0.75 is strong negative, and between 0.75 and 1 is strong positive. If you get a value between negative 0.75 and negative 0.5, and I'll just shade that with a different style, we would call that moderate. And likewise here, that is called moderate. So that would be moderate positive, moderate negative. In this region in here, between -0.5 and -2.5, we'll describe the relationship between the two variables as weak. It's a weak correlation. Weak negative over here, and over here would be weak positive. And if we get a value of Q between -0.25 and 0.25, so something in between there, we would consider that to be no correlation. So that's what the Q value means. It's a number that we can calculate that tells us how strong or weak the relationship is between the two variables and whether it's a negative relationship or a positive relationship. Okay, in order to explain how to calculate the correlation coefficient, we're going to do an example. And in fact, we're going to use the example that's in your textbook in Chapter 4, the example that refers to the depth of snow and the number of skiers. So the story that goes with this is that a person who's running a ski resort wants to know if they can predict the number of skiers that would want to book in at their lodge based on how much snow has fallen that week. And so these numbers here represent data over a number of years possibly. So this is telling us in this particular occasion when the depth of snow was 0.5 metre, then in one given week 120 skiers stayed at that lodge. When the depth of snow was 0.8 metres, the number of skiers that booked were 250. And so this person wants to know if they can use this information to predict how many skiers are going to want to book into their lodge if we knew how much snow is going to fall in a given week. And in order to work out how valuable this data is to predict, we want to know whether it's a strong correlation between these two variables. And the stronger the correlation, the more powerful the prediction value. If there was a very strong correlation, then we could, with a lot of confidence, say that we can predict the number of skiers wanting to book if we knew the depth of snow that's fallen that week. So we would want to calculate the Q value or the correlation coefficient. The first thing we need to do is decide which is the dependent variable and which is the independent variable. Well, I don't think the depth of the snow falling on the mountain depends on the number of skiers up there. I think it's the other way around. So I think the depth of the snow determines the number of skiers, not the other way around. So the depth of the snow will be the independent variable, and the number of skiers will be the dependent variable. Now what you would then do is use a scatter plot or a spreadsheet program to generate a scatter plot to see this data on a bivariate axis such as this. Okay, let's assume that this represents the data plotted on our graph. Now I've just put these dots in randomly. They're not accurate. I'm just using this to explain how we go about calculating the Q value. What we need to do is to break the data into 4 quadrants. And so what we're going to end up with is something that should look like this. We try to split the data with an equal number of data points above and below a line. So we try to find a line where we've got the same number of points above and below it. So I'll just estimate it to be about there. And we also need to find a line where it's the same number of data points on the left and right of the line. So let's say just about there. Now this is not accurate, this is simply to highlight the process. So let's say for a moment I've split my data into a top half and a bottom half, a left side and a right side. As you saw, I've just done this by eye, but that's not really accurate enough. The most accurate way to find this value here, that value there, which splits the data into a top half and a bottom half, that would be the middle value or the median. So to find this point, that value, where we draw our line that breaks the data into top half and bottom half, we look at the vertical axis variable, in other words, the dependent variable, which in this case is the number of skiers. We feed this data into our calculator and we find the median. So once we've found that median of this data, that tells us that value. On the other hand, to break the data into a left and a right side, so it's an equal number of data points left and right of this line here, we have to find the median of our independent variable. And so we look at this data over here and find the median of that data. And that will give us this value here. And so by finding the median of the independent variable and the median of the dependent variable data, we can use those two values to determine these two lines. And so that will accurately break our data into 4 quadrants. Okay, now I've redrawn the graph a little bit more accurately. So we've broken our data into 4 quadrants. The next step is to label each of the quadrants. Starting in the top right-hand corner, we label this quadrant A, quadrant B, quadrant C, and quadrant D. So we've labelled each of the 4 parts of our graph. And now the formula to work out Q is really, really simple. Here it is. Q equals A plus C in brackets minus B plus D in brackets over A plus B plus C plus D. Now, what do the A, B's and C's and D stand for? They are simply the number of data points in each of those quadrants. So all we need to do is count how many of the data points are in each of the quadrants, plug them into the appropriate letter here, calculate this, and that will give us our Q value. Now, a couple of things I need to point out. Any data points that lie on either of our median lines, so that point there, this point here, and this point here, we do not count. So if they're on the actual median, either of the median lines, they are not counted. So next thing then would be to write down A, B, C, and D, and let's actually do the count. So let's count the number of data points in A. We've got 1, 2, 3, 4, 5, 6, 7. So that would equal 7. Number of data points in B, 1, 2, 3. Number of data points in C, 1, 2, 3, 4, 5. and the number of data points in D is 1, 2, 3. Okay, so the actual final calculation to work out Q is going to be A plus C. Well, A plus C is 7 plus 5, which is 12. So that would be 12 minus B plus D. Well, B plus D is 3 plus 3, which is 6. On the bottom, it's going to be A plus B plus C plus D. So it's 7 plus 3 plus 5 plus 3, that is 18. So the answer is 6 over 18. Now if we convert that to a decimal, that would be a value of 0.3 or 0.33. Now if we go back to, if we remember our scale, the value of 0.33 would represent a weak correlation. A weak positive correlation, that is. Now, that's all there is to it. Now, what you're going to do as your exercise is to take the data from the question on the depth of snow and the number of skiers, and you're going to use your calculators to do an accurate scatter plot. You're going to calculate the median of the number of skiers. You're going to calculate the median of the depth of snow, and you're going to do this calculation correctly to see what the actual Q value is for that problem. And I'm going to show you how we can do that using the calculator. Okay, here we are on our CAS calculator, and what I've done, I've entered my data, as you can see here. So the left-hand side is variable D, which is the depth of the snow, and this column here is N, the number of skiers that are actually have booked into the lodge. So you might remember from last term how we can take this data and very quickly work out the median. So I'm going to show you again just to remind you. Remember, we highlight the data, then menu, we go to statistics, stat calculations, and one variable statistics. Now it's going to ask you where to put. It's one list, so we just click one list. It's going to ask us to where we want the data placed or the results placed. Well, we don't want it in column B, because if we put it in column B, it's going to erase the data we've already put in. And it takes a couple of columns to put this data in. So what I would do, I would actually write that as E, so that the data, the answers to this one variable statistics will actually be placed way over to the right and not erase the data we've actually entered. So I'll press OK, and here you can see our one variable statistics. We'll just make sure it's all over here. So the data is still there, and this is the data for the first column. Now if we go down, remember, there's our 5-figure summary, our minimum value, our first quartile, there's our median, 1.95, third quartile, and the maximum. That's the value we want, 1.95. So 1.95 would be the median of the X value. We can then go ahead and do the same with the second column, and when you're asking the calculator to place that data, I would suggest you ask to move it right over, maybe place it over in aisle I or J, so that data will be over here and not erase any of the other calculations you've done. And once you've done that, you can then accurately generate your graph, because you've now got the median for the X and the Y, so you can then do your counts for A, B, C, and D. And just finally, to show you what the scatter graph actually looks like, there's our two columns. Control, new page. We're going to add data and statistics. And there is our data. And that's just randomly distributed. What we can now do is add. Now, remember the x-axis is the depth of snow. We'll go D for depth. And there is the data arranged according to depth of snow. If we now click over on here on the vertical axis and ask what variable we want the number of skiers, that will then arrange it. So there's our scatter plot. And you can see that there's actually it looks visibly like quite a strong relationship between the two variables. So your Q value that you calculate should be, I would think, at least certainly well over 0.5. It's going to be a positive correlation, so I'd be very interested to see what final value you get. Okay, well, I hope that's helped you understand how to generate a scatter plot on your calculator and how to calculate the Q correlation coefficient for that data. Thank you.